We've now laid the foundation for capital budgeting. We've talked about the cash flows and how to calculate the cash flows and the relevant cash flows and the cash flows that aren't relevant. And what we're ready to do now is turn our attention to actually using all of these cash flows to come up with some sort of decision about each project and determining whether or not that project would be beneficial to the organization or not beneficial to the organization. In this video, we're going to look at the payback method and the discounted payback method. But before we get to those, just kind of here's an overview. What are the capital budgeting methods that we're going to look at? And there are 4 of them that we need to look at. And these 4 methods are what are called screening methods, which means we're simply going to determine whether or not this project is beneficial to the organization. Would this be a positive investment for the organization? Would it help the organization? Would it improve the organization? And after we've determined all of the investments that are beneficial to the organization, then the second step in the process is trying to determine which investment we should make first, second, third, and so on until we run out of available money. And we'll look at that process a little bit later. But here we're just trying to determine whether or not an investment is a net benefit to the organization or not. Now we've got 4 methods that we're going to look at here. And it's possible that we use multiple methods to evaluate all of the different investment opportunities we have. And we're going to use other things as well. We're not only going to look at these, we're going to look at all of those qualitative factors as well. Things about quality and worker safety and our relationship with the community and customer goodwill. Anything else that's not financial, but still part of this decision in terms of what is the best course of action, the best option for our company going forward. So the 4 screening methods that we're going to look at, we're going to look at the payback period and the discounted payback period, and those are, as we can guess, fairly connected to each other. And then we're also going to look at the net present value and the internal rate of return methods as well. So those are the 4 methods that we're going to look at, the 4 capital budgeting methods that we're going to look at. But we're going to start by looking at the payback method. And the payback method is fairly straightforward. It's fairly simple. What we're calculating with the payback method is simply how long it will take before the after-tax cash inflows that we receive from this investment are going to be equal to the amount of that initial investment. Or how long is it before the cash inflows pay back the amount of that initial investment? How long will it take us for us to get our money back? We had to spend $200,000 to invest. Well, how many years is it going to take us to get $200,000 of inflow? 2 years, 3 years, 10 years, 20 years? How long will it take us before the cash inflows pay back that initial investment? If we have a situation where the incoming cash flows are constant over the project life, which is very possible in an exam question. Every year it's $50,000. Every year it's $70,000. Whatever the case may be. When we have a situation where the cash flows are constant over the life of the project, the payback period calculation is very simple. It is simply that initial net investment divided by the periodic constant cash flow. What is that cash flow that we're going to get each year? And this will tell us how many years it's going to take. If we have a $200,000 initial net investment and we have $50,000 a year coming in, well, it's going to take us 4 years. Okay. This is the calculation. It's very simple when we have constant cash flows over the years. Okay. Each year we have constant cash flows. When the cash flows are not constant, then it becomes a little bit more involved. It's still not difficult, but it's not quite as simple as this. But we'll look at an example of that here in just a little bit. Before we go any further, let's talk about some of the advantages and the disadvantages of the payback period. First, the advantages of the payback method. Well, the first one's a big one and it's important. It's simple and it's easy to understand. You don't really need to have a lot of financial background to wrap your mind around this. It's how long until the cash inflows equal that initial investment. So it's simple, it's easy to understand. And because it's simple, it's very useful to be used as a preliminary screening when we have a whole lot of proposals in front of us. We might say very simply, payback period needs to be 3 years or less, 5 years or less. And so right away we're able to say, okay, this project does not have a payback period that's fast enough, so we're going to exclude it. It's also useful when expected cash flows in the later years of the project become more uncertain. The further into the future we go, the more of a projection, the more of a estimate, the more of we don't want to say it, but the more of a guess we're making as to what those future cash flows are going to be. And so with the payback method, we stop after we get to the payback period. Once we get to year 4, once we get to that payback period, those future cash flows after the payback period are not involved in this calculation. And so those less certain cash flows in the later years of the project never really come into consideration here with the payback method. And finally, it's also helpful if we want to recoup an investment quickly. It's able to make a very quick assessment, 2 years, 3 years, 5 years, whatever is quickly for our business and for our industry. But we're able to use this to make certain that this investment isn't going to drag on for long periods of time, because the longer the period of time before we get the payback, the greater the risk. Okay? The longer the time of the payback period, the greater the risk that we have in connected to this investment opportunity. Now, the weaknesses of the payback period. Well, we said that one of the strengths or one of the advantages is it ignores all of the cash flows beyond the payback period. But that's also a weakness of the payback period, because maybe the project is going to have some really large cash flows later in its life. But they're not taken into account if there's a ramp-up period. Okay, those large cash flows that come 7, 8 years down the line may not make it into the payback method calculation because they happen so much later, and we're not taking those into account. What we've talked about so far with the payback method, a weakness is it also ignores the time value of money. Okay? And connected to that, it ignores the cost of capital. We don't have a return that we're looking for on this. Now, you may have guessed that the difference between the payback method and the discounted payback method is that the discounted payback method does take into account the time value of money, but we'll get to that in just a moment. What we want to do now is look at the cash flows that we set up from our example, and we're going to calculate the payback period for CMA products when we had those unequal cash flows. Okay, when we had those unequal cash flows as part of the project that we had. So going back, this is the numbers we set up in that example, nothing different here. We've got the time periods here, and we've stopped after year 5 because we don't need year 6 and beyond. But what we have here is all of the different cash flows, and down at the last 2 rows we have the total after-tax cash flow for each year, and then the cumulative cash flows for the project, what those cumulative cash flows are for the project. And it's those cumulative cash flows that are what we're interested in. If we look at this, after we make the initial investment, our net position is minus 150. After year 1, when we had a $40,000 cash inflow, our net investment, our net cumulative cash position is minus 109,641. Then in year 2, we had some more inflow. In year 3, we had some more inflow. And so at the end of year 3, our cumulative cash inflows were minus almost $24,000. But then in year 4, we have $39,000, almost $40,000 of cash inflow. So at the end of year 4, our cumulative cash flows are positive. And so it's this transition from negative cumulative cash flows to positive cumulative cash flows where we know that the payback period has taken place. And so we know, just looking from this, that at the end of year 3, we're still negative. At the end of year 4, we're positive. So somewhere during that 4th year, 3 point something, our cash inflows equaled the cash outflows. Now, we always make the assumption that the cash flows happen equally over the course of the year. And so calculating this decimal, 3 point something, simply becomes a math problem. And this is how we go through it. We know that the cumulative cash flows become positive in year 4. So there are 3 years that have negative cumulative cash flows. So we need to calculate how far through, what percentage of the year in year 4 do we get to 0. Now the way we set this up is with a numerator and a denominator. The numerator is what are those negative cumulative cash flows that we had from that final negative year. So the minus 23,898. So we need to get that much. And then the denominator becomes what were the cash flows for year 4. 39,684. So that 23,898 divided by 39,684, that tells us what portion of year 4 was required before we get to 0. before we get to a cumulative cash flows of 0, and that's 3.6 years. Okay, just a very simple math problem there to determine where it is that we get to 0 in that 4th year. Okay, so fairly straightforward when the cash flows are the same every year, and it's really not difficult when the cash flows aren't the same every year. We just have to calculate that cumulative cash flow and determine what is the year where it switches from negative to positive, and then do this math here to make that calculation to determine exactly how far through that year it is that we get to 0 as our cumulative cash flows. So that's the payback method. We're now going to turn our attention to the discounted payback method. And what the discounted payback method does is it addresses that weakness in the payback method of not considering the time value of money. What we're going to use in the discounted payback method are the present value of those future cash flows instead of the undiscounted cash flows. And we use those discounted present value of those future cash flows to calculate the payback period. So there's an additional step, and we'll do it here. We'll look at the example here in just a minute. Additional step in this, but it's not difficult. It's just an additional mathematical step that we need to go through. Now, something to keep in mind though. The discounted payback period will be longer than the payback period. If the payback period is 4 years, the discounted payback period is going to be 5 years or 6 years or 7 years, depending on what our interest rate is that we're using to calculate the present value. Because of that process of discounting those future cash flows, we're making them smaller. Because $100 10 years from now is not worth as much to us as $100 right now. And so what we're going to do is we're going to take that same example, but we're going to calculate the discounted payback period, assuming a 10% required rate of return. Okay, so we're going to calculate the present value of all of those future cash inflows using a 10% present value, or I'm sorry, 10% interest rate to calculate that present value. Now, this takes us to the tables and how it is that we use the tables in order to get the question correct, in order to make these present value, these discounted calculations. If you have one of the few approved financial calculators and you know how to use it, you can use that. But if you don't, you need to use the tables, and the tables will be given to you. You'll have access to the tables if you need them during the exam. So here we have the table. On the left side, we have the number of periods. Across the top, we have the interest rate. And what we have to do is find the table values, and this is the present value of $1, just a single sum. We need to know what interest rate we're looking at. We already said we're looking at 10% in this question. That's the required rate of return. And so what we're going to be using is those table values for the appropriate number of periods. Now, we had 9 years in this project, in the example, but we don't use all 9 of them here in the discounted payback period. But what we're going to do is we're going to take that cash flow in year 1 and multiply it by 0.909. We're going to take the cash flow in year 2 and multiply it by 0.826. It just becomes a very large math problem. So if we take that same table and now we're just adding a row to it. We had our total after-tax cash flows for each year. And now we need to get the discounted cash flow for each year. And we get that by multiplying that annual cash flow by the table value. There's the 0.909, the 0.826, and so on. And this allows us then, when we have those discounted cash flows for each period, to calculate the cumulative discounted cash flows at the end of each period. And we have the same problem here, or the same situation, I guess, where it starts out negative, minus 150, and then it gets a little bit less negative each year. At the end of year 4, we have a negative $18,503 negative cumulative cash flow. At the end of year 5, it's a positive $5,312. So it's that somewhere there during year 5 that we get to 0. And so, even though this is the discounted method, and we had that one additional step there to calculate the discounted cash flows, the process is still the same once we get to this point. We know it happened sometime during year 5. There were 4 years where it was negative, and so we need to calculate when during that 5th year it happened. The final negative amount was $18,465. The cash flow for the fifth year, the discounted cash flow now in this case, is $23,812. And we do the math and it is at 4.78 years. Longer than the payback period. Okay, the payback period was shorter than this. The payback period happened during year 4. Okay, the payback period was 3.6 years, and now it's 4.8 years when we take the discounted cash flows, but we knew it was going to be longer. So those are the two payback methods, payback method and the discounted payback method, using the cash flows, just determining how long it takes before the net cumulative cash flows for the project get to zero. It starts out negative because of that initial investment. How many years will it take before the cumulative cash flows for the project become zero? Again, simple, straightforward to use, good way to screen a lot of options right away, good way to screen for looking for short payback periods. But if we want to take into account the time value of money, if we want to take into account that interest rate, that required rate of return, then we need to use the discounted payback method, which is just a little bit more sophisticated than the payback method. So those are the first of the two methods that we're going to look at. And what we're going to turn our attention to next is the net present value method.